Okay, I'm going to try to wrap up 15.3 and not have this video be too long, but we have 4 problems to do. A lot going on here, but we'll try to take them one at a time. Here is this function that's says to be given the value of a machine after a certain number of years, and this is what the machine originally cost. And then this function here, when we plug in the rate that this machine is going to decline in value into this function here, plug in all their values, the original cost, and then the rate and the time, and we plug that into our calculator, and then the value depreciates to $1,079.21. Okay, so hopefully you can work that one out pretty easily. This one's a little different because we have 2 functions here, and we have this revenue function that says we take the number of units that we sell times this P of X here. And so what we're going to do here is we're going to put this P of X in here, letting the X value be 10 units sold. And so we have this that we compute first with the 10, and that gives us this $4.17. Okay. And then we're going to take this and we're going to put it back into the original function here. So we're going to take this value, we're going to take it, put it back into here. All right. And so that's that P of 10. So what we get for our revenue is we get revenue of 10 units is equal to 10, that's that X value, times 417, and then we get 4170. Okay. Not a huge revenue, but a nice little example of calculating one function first and then putting it into another function. Okay. Now this one right here talks about the concentration of a drug in the blood stream after T hours, or T minutes, excuse me. And so we're going to put in 30 for T, and again, this is just a calculator problem, and we can come up with 0.599 units. And if you want to read about what types of units those are for blood concentration, there's kind of a lot of different theories on that, as it gets kind of complicated, but just some practice using a function here for that. So now this last one here, and I did want to fit 4 onto this page, talks about a contagious disease, and this value is the start time of 0, and this function is how the disease spreads, or how many people get the disease in the population. And so if you put 0 in here as the start time, what ends up happening is you get 12,300 divided by 1,000, and it equals approximately 12.3 people, but I think it says round to the nearest person, so we'd have 12 people were initially ill. Okay. Then when we put in after 12 weeks, and we just put this in our function, now you should be able to put this into your calculator here, just like this, using your fraction key on your TI-84. And when you calculate that, what ends up happening is you get approximately 12,225 people. So if this model holds true, almost everybody in the town becomes ill with this flu virus or whatever virus it happens to be. So hopefully these go okay for you. Again, substitute correctly and be careful with your computations, and work with your calculator till you achieve these answers. That's it for 15.3.